This video is to introduce to you the basic concepts of truss. First, suppose we need to construct a bridge across a little river. For a little river, we can use a beam, like a simple tree trunk, as a bridge to cross the river. Difficulties and solutions. But when the river is getting wider, we need a longer bridge. To extend the length of a bridge, we can use a longer beam of the same size, but with an additional support. However, it will be very expensive to build the additional support if the water is too deep or the bridge is too high. Another method is to use a larger beam, that is, a beam with a bigger cross-section, in order to carry the load. Truss bridge. However, such a beam would be very heavy and expensive to build. In order to reduce the weight, some of the materials could be removed. The resulting truss structure would be lighter and be able to carry loads over a large span. Let's consider some simple trusses. To simplify the analysis, we assume that all members of a truss is straight with no weight, and the loads are only applied at the joints. Two types of joints. Next, consider how two members are connected. Let's say we have two pieces of wooden member. If we use one nail to connect them, then the members can rotate relative to each other. This type of joint is called a pin joint. Now, suppose we use more nails to connect the members. Then, the members cannot rotate relative to each other. This type of joint is called a rigid joint. Basic truss structure. For a truss, we assume that all joints are pin joints. The simplest form of truss is a triangular truss. Even though all joints are pin joints, the structure will be able to resist any load from any direction. It remains in equilibrium. By combining two triangular trusses, a square truss with a diagonal members could be formed. It is also able to resist any load from any direction. However, if we remove the diagonal member and apply a horizontal load at the top left corner, the structure will shift and collapse. It will not be able to resist the horizontal load. Forces on truss joints and members. For a basic triangular truss, it has 3 joints and 3 straight members. We can use the equilibrium conditions to find the reaction forces F2 and F3. As the whole truss is in equilibrium, every joints and every straight members of the truss are also in equilibrium. For example, consider a joint A. We know the given load, F1. And we know that there are 2 member forces acting on the joint. As joint A is in equilibrium, we can use the equilibrium conditions to find the member forces. We can use the method of joint to find the unknown forces. We will introduce this method in the next video. After we find P1, it is called the member force acting on joint A from the member. By Newton's law, action equal reaction, we know P1' is equal to P1. Member P is in equilibrium too. Therefore, P2' is also equal to P1'. And it is called induced force in the member. When the forces are pointing to the center of the member, it is called compression force. While the forces are pointing away from the center, it is called tension force. While there are many kind of typical trusses that we can use, which one should be more suitable to use in a given situation? We will learn more about this in the lecture and the following video.